Welcome back to the Home Lab, and today we're celebrating 5,000 subscribers, so thank you very much for that. I've got an absolutely fascinating thing to show you today, and a video I've been meaning to make for a very long time. This is a bit of physics that once you've seen it, you're going to see it all around you. It's a very strange effect called the tennis racket effect or the Dzhanibekov effect. So let's kick off straight away and have a look at this really weird and interesting effect. So imagine you're wanting to hammer in a nail and you start hammering in the nail and then suddenly you think, actually, I don't want it there. So you want to remove that nail. Well, you've got to change the sides of the hammer. So how do you do that? Well, you use the tennis racket effect or the Dzhanibekov effect, and you just throw the hammer into the air, catch the handle after one rotation, and the hammer seems to have swapped sides, so you can go straight away down to the nail and pull it out. Now, this is a really strange effect. Now, those of you who know me well will know that my coordination when it comes to trying to catch things is absolutely hopeless. So I'm not doing anything clever myself here. I'm not actually putting a twist into the handle as I throw it into the air. I literally just throw it into the air and try to catch the other end. And if I do that, I just find that the hammer head and the claws on the other side have just swapped sides for no apparent reason. And this is the Dzhanibekov effect, or it's often demonstrated with a tennis racket, though to be honest with you, I prefer to demonstrate it with something else, because a tennis racket has both sides of the racket look very similar, so unless you colour them differently, you don't see this. But by all means, try it with a tennis racket. It works with a hockey stick or whatever you've got, as long as you can fling it into the air and catch it. So to sort of see what's going on, and it's actually rather difficult to visualise, have a look at this video of Steph throwing a pair of scissors into the air. And this is a classic example of a situation where you've got used to the Dzhanibekov effect and you just pick up all sorts of things and play with them. And a pair of scissors works really well, though just watch yourself when you do it. You'll notice the scissors go into the air, but as they rotate around one axis, they also twist as well. So when she catches them, the handle has swapped sides. So there are a number of names for this effect, and you've heard me call it the tennis racket effect, because if you do it with a tennis racket, you see this sort of flipping happening. But it's also known as the Dzhanibekov effect, because in 1985, a Russian cosmonaut was playing with some objects in weightlessness and noticed that when he rotated objects, they also did this very strange flip as well. But of course, because he was in a falling frame of reference and the object was falling at the same rate, it sort of stayed in front of him and did this very strange twist and flip. So you can see videos of that on YouTube. I'm told that the effect that they discovered was kept secret by the Russians, but in fact there's mentions of this effect in textbooks going back to the 1830s. And it goes under another name, the intermediate axis effect. So what we're going to do now is make some attempt to explain how it works and particularly why it's called the intermediate axis effect. So for a little bit of an explanation. For this effect to work, the intermediate axis effect or the intermediate axis theorem, you need a rigid body that's got 3 axes of rotation. So this hammer can rotate around this axis, it can rotate around this axis, and it can rotate around that axis. And those 3 axes have different moments of inertia. What I mean by moments of inertia is the mathematics of how spread out the mass is from the centre of rotation. I'll keep it as simple as that. So when you rotate it along this axis, the mass is actually the mass of the hammerhead is quite close to the centre of rotation. When you rotate it around this axis, which is the one we've been using, the mass is further out compared to the axis of rotation. And if you rotate it around the third axis, which is this one, you can't see it easily, and I spent ages trying to find a way of explaining this, but in fact the moment of inertia there is even larger. The mass is sort of further away from the centre of rotation. So where are we now? We've got three principal axes of rotation, and we've got one with a very low moment of inertia, one with a medium moment of inertia, and one with a high moment of inertia. So let's see what happens when we rotate around these three different axes. So let's look at rotations around these three different axes. So remember, you've got the low moment of inertia, first principal axis, second moment of inertia, which is a bit bigger, so that's the second principal axis of rotation, and finally the third one with the high moment of inertia. Now, I'm not going to do this in the air, but if I rotate around this first one, the low moment of inertia, it's actually a stable rotation. If I was to, I wish I could do this in zero gravity or weightlessness. As you rotate this way, any perturbations in the second or third one I've mentioned cancel out and keep this axis stable. The same applies with this third high moment of inertia one, that any perturbations or slight changes in this one caused by the other axes tend to cancel out. But it's the middle moment of inertia, this one, the sort of tumbling one that we've looked at. The slightest perturbation in any of the other rotations causes this one to flip as it rotates. And that's about as deep as I want to get into it, because you need some quite interesting maths to try and explain this, and we still sort of argue about what happens. So what have we got from that? We've got three moments of inertia, a low one, a medium one, and a high one. The low moment of inertia is a stable rotation. The high moment of inertia is a stable axis of rotation. It stays on its axis. But if you rotate it around its second medium moment of inertia axis, it's actually unstable, and that's where the flip happens. Once you've got this effect to work with an object at home, I think you'll start trying it with all sorts of things, and that's exactly what I find myself doing. So you pick up the pan washer, and you think, oh, that's upside down, so you just flick it like that, and it's now the right way up. And I find myself doing it with lots and lots of things. I'm going to drop this. I know I'm going to drop it, but try again. A bit of Barry's Brio track, and it's got the railway lines on the top, and I flip it. Yeah, well, I did sort of caught it, and we're now on the smooth side. Let's try that again. So we got the track, and now the smooth side. So you'll find yourself doing it with lots of things. Do try it with a ping pong bat, because they're often sort of black and on one side and red on the other. So when you do it, you notice the colour change, so you know that it's flipped. Or a tennis racket, but you might want to remember which side is which, so you actually see the effect happening. Please, in the comments, once you've got this to work, please write in the comments what object you got it to work with. There are so many things. I've seen people doing it with mobile phones and what have you, but don't drop that one on the floor. But I'd be interested to see how you can get the tennis racket effect working for yourself. So I do hope you enjoyed that video on the Dzhanibekov or tennis racket intermediate axis theorem, whatever you want to call it. And a bit of a celebration of 5,000 subscribers. Thank you so much for supporting my little channel. I'm glad you enjoy the videos that I make. I have great fun sharing the physics that I enjoy. Anyway, if you get this to work, do put something down in the comments. I do appreciate that these videos aren't really rigorous or mathematical explanations of things, and I know that disappoints some people. But as you probably worked out, what I do is I produce videos to kind of show you things, to get you thinking. And once you're out there, then you can go and explore a little bit further. Anyway, I'll be making another video very soon, and do please join me then.